Hello friends, in this video tutorial we are going to create this particular sheet metal job. So let's look forward. What we have is the front view of the part and the top view, and here we have the side view. As you can see, the bending radius for this particular job is half inches. The width of the, or we can say the thickness of the sheet metal is 1 by 4th inch. Okay, so using this dimension we are going to create this particular part in sheet metal, Solidworks sheet metal, and after we'll be using the flat pattern, and from that flat pattern we are going to create the DFX files for the manufacturing processes. So let's have a look how to do this procedure using Solidworks sheet metal. So for that, let's go to file, click on new, and let's select a part template. And from here, let's start creating the job. So first of all, we'll create the side view, and for that we'll select the right plane and let's select sketch. To create the side view, I will follow such steps. I will create a L shape using the line commands. Okay, as you can see in the side view, the bending radius or the inner radius is half inches. Okay, and the thickness of the sheet metal is 1 by 4th of an inch. So the bending radius is half inches. For that, we'll use the fillet command, use fillet, and specify 0.5 inch. Okay, and create a fillet over here. Okay, so as you remember, the thickness of the sheet metal is 1 by 4th of an inch. So for that, you'll use the offset command, and let's specify the dimension 1 by 4th. This will be the offset distance, and let's select the lines, and over here you have to select the cap ends and lines to create the ends for this particular side view. Click on OK. So here we have the side view with the internal radius to be half inch. Okay, so now let's go back to the drawing. So in the drawing you can see here we have the dimension 6 inches. This is the overall length, and the overall length over here is 7 inches. So let's specify it. So let's select smart dimension and let's select the edge, this one and this one, and let's specify the dimension 6 inches. And now over here, let's specify the different dimension, that will be 7 inches. So here we have the side view. So here we have the side view with proper dimensions and constraints. Okay, so the next part will be to give length to this object. For that, let's open the job. So here we have the length 4 feet 9.5 inches. So let's specify it. For that, let's go to features and let's select extrude, and let's specify the direction. Okay, and the width. So for that, we have the depth is 4 feet and 9.5 inches. Specify it and make it okay. So here we have the part, okay, with a bend, as you can see, which we specified half inches. One thing more, we have some holes over here on the top view. So let's see. So for the holes, we can see the diameter is 2 inches, and we need some more specific dimensions to specify the orientation of the holes. For that, we can see that the horizontal dimensioning is 1 feet and 1 by 8th of an inch, and vertically it is 2 inches apart from this edge. In this particular drawing, we can see this is the top face and the edge is about 6 inches. So these holes are located on the top face, having the edge about 6 inches. So if you will click over this object, you will see here we have the 6 inches top face. So let's select this top face and select sketch. So here we have the top face. Now let's change the orientation as given in the job. So here we have the orientation. As you remember, the hole diameter was about 2 inches. So let's create a hole using the circle command. Create a circle and specify the dimension using smart dimension. So it will be about 2 inches. And as you remember, the horizontal offset or the horizontal gap from this edge to this hole was 1 feet 1 feet and 1 by 8 of an inch. So here we have the horizontal dimensioning, and let's specify the vertical dimension, which was about 2 inches. Okay, so let's mention 2 inches and click OK. So here we have placed the first hole perfectly. Okay, and now let's see the rest of the holes for this object. Let's go to the job, and here you can see we have the specifications for the holes. 3 equal spacing at 1 feet equals to 3 feet. So there are 3 equal spaces. That means we have 4 holes over here for this job. So let's make 4 holes. Okay, to create 4 holes, we'll select linear sketch pattern, and let's select the entities to pattern. Here we have this hole, select it. Okay, now you have to change the direction and specify the gap between the holes. Okay, so here you can see the gap is 12 inches and the instance is second. So now from here, let's increase the number of holes. We need 4 holes, so here we have the 4 holes, and now click on OK. So now the holes have been created. Next we have to use the extrude command. For that you have to go to features, and here we have the extrude cut command to create the holes. Select extrude cut. Okay, and from the direction one, you can change it from blind to through all to create the holes specifically for the sheet metal, and make it okay. So now the 3D part is done. We are done with the 3D part. Now we have to make this 3D part into a sheet metal object. For that we will go to sheet metal, and here we have this command, convert to sheet metal. So we'll be converting this particular object into a sheet metal object. For that, select this command, and now you can see it is asking in the sheet metal parameters fixed entity. So we have to select a fixed face. For that, let's select this face. So it will be our fixed face in this example. Okay, next we have the thickness. So the thickness is 1 by 4 inches. That is perfect. Okay, now we have the bending radius. So the bending radius was half inches. So let's specify half inches. Okay, now next we have the bend edges. So we have over here, select this bend edges. Okay, so we have specified the bend edges, and next if we'll go down, you will see bend allowance. So to create a perfect flat pattern for a sheet metal job, it is very much important to select the perfect bend allowance. So in this tutorial, we are going to use a calculator from Google. About the calculator, I can give you the link in the description. You can go to this link and you can have an access to the calculator. So let's open it. So here we have the calculator over here, and now you can see here we have the bend allowance calculator. So the radius of bend, it is 0.5. Okay, which is matching to our job. The thickness of material is 0.25, that is 1 by 4 inches. Angle of bend is 90 degrees, and now we have to calculate the bend allowance. For that, let's click on calculate bend allowance, which is equal to 0.95. So this is the value which we are going to put into the SolidWorks sheet metal. So 0.959. Okay, so here we have the bend allowance, and let's put the value 0.959 and then click on OK. So we have given the precise bending allowance for this job. Okay, so now let's make the orientation of this particular part as given in the job. So let's make this face as current. Okay, and now to make the DFX files, we have to create the flat pattern for this object. For that, we have to go to file, and let's select make drawing from part. Okay, and now let's save this drawing or the part. So let's save it. Okay, now let's go to file, click on make drawing from part, and let's select the drawing template. So here we have the drawing sheet, and let's create the views for the particular job in this drawing sheet. For that, let's go to the view palette, and here you will see view palette. Let's click over here. So here you will see the different views for this particular job. Let's select the current view and place it over here on the drawing sheet. From here, you can create the front view. So in this manner, we have this front view over here. And now let's create the side view for this particular job from the front view. For the select projected view and select this view. So here you will have the side view. Okay. So now we will consider this side view and we will apply annotations to this view. For that, we will go to dimensioning, annotation, smart dimension. Okay. And now let's see how we'll define this with particular view. For that, let's select this edge and let's select the inner edge. Here we have the first dimension. Now select the edge and now we have to select the outer edge of the sheet metal. Okay, so here we have this side done. And now we will do the same with this edge also. So here we have the edge and now select the inner edge, place it, then the outer edge in reference to this edge. Okay, so here we have the dimensioning. Okay, and now let's define this thickness. Here we have 1/4 inch and this one, that is 1/4 inch exactly. And next we will specify the radius, the bending radius. For example, here we have 1/2 inches. So this is the side view, and let's uh, compare this side view with the side view which was given by the customer to us. So here you can compare the side views which we got from the customer side and the side view which we created just. So you can see here we have 7 inches on the left and the inner dimension is 6 inches and 3/4 inches. So 6 3/4 inches, and on the top we have is 6 inches and 5 3/4 inches. So 6 inches, 5 3/4 inches. Okay, and the radius of bending is 1/2 inches, which is same. So everything is perfect. Now let's place the flat button over to the drawing sheet. Drag and drop. Click on OK. Here we have the flat button, but the orientation is not what we need. So click over here and right click over this flat button and select rotate. Select rotate view. Apply 90-degree angle. Okay. So here we have the rotated flat button. You can drag and drop it anywhere, but you can see it is not oriented to any of the views. For that, you can select this flat button view, right click, and here we have the alignment. So in this particular case, we will be going to use align vertical by center. Click over here and let's select this particular view. So our flat button is aligned to the center of this view which we have, that is the front view. As you can see, our flat pattern is missing the bending line over here. So let's make them visible. For that, you have to go to view, hide, show, and here you can select bend lines. Okay, so here we have the bending lines over here. To create a perfect flat pattern, we don't need the center marks for the holes. Let's select and delete them. So these are the instructions for the workshop. It means that you have to bend the portion above this line at an angle of 90 degrees, having the radius of 1/2 inch. Okay, so these are the instructions for the fabrication. Let's select annotation and smart dimension. So now let's select this edge over here and let's select the bending line and place the dimension. Similarly, the edge and the bend line, and let's place this dimension over here and let's select the overall length. So in this you can see 5 3/4 inches for this flat pattern, and in the job we have the same 5 3/4 inches which is matching. So it means the flat pattern is perfect. Now let's check for the rest of the part. 6 3/4 inches from the bending line till the edge, 6 3/4 from the bending line till the edge. So this flat pattern is absolutely matching the requirements given by the customer. So this will be our flat pattern for the given job. Now to manufacture this sheet metal object, we have to convert this drawing into DFX file. For that, you can go to File, Save As, And from here you can select save as type, and you can change the file type to DFX. Okay, and click on save. So we have just converted this particular drawing into DFX format. The aim of doing such is to generate the input for the laser cutting CNC machines. The flat pattern will be laser cut and required bending will be given by different mechanical processes to obtain the particular sheet metal object. So I hope that with this video tutorial, you can easily create a perfect sheet metal pattern using a precise bending allowance for the manufacturing processes. Please hit like button and subscribe if you like this video. Thank you.